So just writing down the equation of a circle, so don't forget. This is the equation of a circle as centre AB and a radius equal to r. This is the length of a line, because I think I might need that in this question as well. I should have all of these equations, all these formulas at the top of my brain, just ready to use them whenever I need to. Okay, so we've got two circles. This one here, one's got a radius 5, this one's got a radius 15. Show that the C1 and C2 touch. Okay, if these two circles touch each other, okay, one circle next to the other one, okay, doesn't matter where they are at the moment, let's just think about that. If they touch each other, they meet exactly there, they just touch at the end. So the one with the radius 5 and the one with the radius 15 just touch each other. That means that distance between the centre of the first one and the centre of the second one must equal the 5 plus 15. The distance between the two centres must be equal to 15. So that's what I need to show. So the distance between the two centres must equal 15. Okay, so to show that the distance between the two centres, calculate the distance between 2 points. So between minus 2, 9 and 10 minus 7, that length, distance 9 minus minus 7 plus minus 2 minus 10. Make sure, remember, you get these in the right way around. So that one was first and that one was first. Okay, that one's second and that one's second. Okay, L squared, that's going to be 16 squared plus 12 squared. L squared, 16 squared, allowed a calculator. Is it 256? 256 plus 144. L squared equals 400. L is equal to 20. Doesn't equal 15, does it? I said it was supposed to equal 20. Okay, that's that first bit done. So you've shown that they're equal to 20. So the distance between the 2 points is equal to 20, so they must just touch at that point. Okay. Given that the circles touch at the point 1, 5, find the equation of the common tangent at P. So, common tangent at P, let's just visualise a little bit more detail what this looks like. It said, right, let's have a little sketch. We've got one circle that has centre minus 2, 9. Okay, that's the point A, and it's got a radius 5. So radius 5 means it's going to kind of go somewhere like that. It's not the best circle I've ever drawn. I can kind of see what's going on. C2 has centre at 10 minus 7, so that's down here. It's got a radius 15, and we know that they, something like that, they just touch. Okay, we know that distance between there and there was 20. Despite me thinking it was 15 for a minute, it was 20. And they just touch. It says they touch at the point here where they touch, that's the point 1, 5. We need to find the equation of the tangent. The common tangent just means they both share it, that point. So there's a tangent going through here. We know the tangent, I should make it my drawing a bit better. We know the tangent meets the radiuses at 90 degrees, okay, or the radii. So that was minus 2, 9, this one was 10 minus 7. So tangent meets the radius at 90 degrees. So we need to find out the gradient of one of these radiuses. So I'm going to look at this gradient here. I'm going to find the gradient of that line. So the gradient of AP. We know change in y's over change in x's. Make sure you get this right around. I'm going to do 5 minus 9 over 1 minus negative 2 minus 4 over 3. Okay, that's the gradient of this line AP. Therefore, the gradient of the tangent, negative reciprocal of that, so that will be 3/4. Okay, even with my rubbish sketch, it looks like it's got a positive gradient. Okay, so equation of a line, or the equation of the tangent. Notice each time I'm writing down exactly what I'm doing. Gradient of AP, gradient of tangent, equation of the tangent. Y minus y1, talked about that before, you should be using that. X minus x1. So point on the line, the only point that we know is on that line is 1, 5. The y coordinate is 5, the gradient is 3/4. X minus the x coordinate is 1. Times both sides by 4, Probably doesn't matter which, doesn't ask for a particular form, so you can do what you like with that. You could leave it there and you would get the marks. You can make it all equal to 0 if you want. 3x minus 4y plus 17. Okay, but this would be enough on this question because it doesn't ask for it to be in a particular form for you to get the answer. 7 marks for all of this big long question. Finding the length between 2 points, got your 1 method mark. Okay, actually getting that was 20 was 1 mark, and knowing that it had to, showing a little bit of understanding, so that sentence that they must equal 20 is equal to 1 mark. This was actually an answer mark, wasn't a method mark. My apologies. Okay, the gradient, finding the gradient of this bit of line or this bit of line or that line, that'll be the same, it's the same line. Finding that gradient, doing it correctly, 1 method mark and 1 answer mark. Sorry, you can't see that. 1 method mark, 1 answer mark. The next bit, finding the gradient of this, the tangent, being the negative reciprocal, 1 answer mark for writing that down. Using the equation of the line to get the right thing, your final answer mark. 1, 2, 3, 4, 5, 6, 7. Okay, right. Let's have a look at this next bit then. Gareth claims, who's been asked by his teacher to investigate the properties of another circle, blah de blah, that the equation of the circle claims that this is given by actually that blah blah blah. Properties of this circle. So we've got x squared plus y squared plus 4x minus 6y plus 20 equals 0. How can this not be correct? How can this not be the equation of a circle? 3 marks. Well, we know the equation of a circle. We normally get it in this form. So let's see if we can put it into that form, see if it is an equation of a circle. So think about all your x bits. I'm going to write them next to each other. X squared plus 4x, y squared minus 6y. I've got plus 20 on the end. Okay, so complete the square for this bit. Half the x coefficient squared, take away 4. 2 squared is 4, so take away 4. Do the y bit. Y minus 3, half of minus 6 is minus 3. Minus 3 squared is always 9, so take 9 away. Plus 20 equals 0. I'll write this in a little bit more succinct fashion. So collect together your your minus 4, your minus 9, your plus 20. That's going to give you plus 30, nope, plus 7 equals 0. Okay. So if you try to put that 7 on the other side, obviously you could, but be minus 7. Okay, this would imply a negative radius. Okay, it's not possible. Okay, the radius must be positive. Okay, you try drawing a circle with a negative radius.